Welcome back, mathematicians. In this video, let's discuss radical equations. So first, what is a radical equation? Well, it's when a variable occurs in a radical. So in other words, if you have a radical, the variable must occur inside the radical. In other words, the expression that you are taking the square root or the third root of. So in this case, the square root of x is equal to 4 would be an example of a radical equation. Well, because of the fact that you're taking these square roots or even roots, there can exist what's called an extraneous solution. An extraneous solution is an apparent solution that are not solutions of the original equation. So in other words, what you're going to find is that you will solve the equation and you could possibly get one or two solutions. And what you need to do is go back and substitute those solutions back into the original equation. And what you might find is that one or both, maybe all of the solutions don't actually work out to the original equation. And that happens because of the fact that we're dealing with a radical, okay? So it can happen, it doesn't always happen, but we need to check for it. So again, those solutions that you get that don't actually work for the original equation are called extraneous solutions. Let's now solve these two radical equations, and don't forget that at the end of it, we need to check our solutions to make sure to verify if we have any extraneous solutions. Let's start with the first one, and we're going to add 2 to both sides. So we're moving the constant over, and we're isolating the radical. In this case, it's a third root of 2x minus 4, and it's equal to 2. Now, we want to undo the radical. In other words, we are going to cube both sides in order to undo that radical and cancel it out. So what we end up getting is 2x minus 4 is equal to 8. 2 times 2 times 2 is equal to 8. Then we're going to add 4 to both sides. So we have 2x is equal to 12 and divide by 2 to both sides. And so x is equal to 6. So again, what we have is an apparent solution, and what we must check is to see if that actually works for the original equation. So to do this, what we're going to do is replace the variable x with 6 and simplify the left side. So we have the cube root of 2 times 6 minus 4 minus 2 is equal to 0. Okay, well, 2 times 6 minus 4 is equal to 8. So we have the cube root of 8 minus 2 is equal to 0. The cube root of 8 is 2, so it's 2 minus 2 is equal to 0. And so 2 minus 2 gives you a difference of 0 is equal to 0 on the right side. So this actually does work. So 6 is your solution with no extraneous solutions. Let's go to the next one. And the next one, what we notice, we have a radical isolated on the left, which is what we want. So we always want to have the radical isolated equal to an expression, a number, maybe a variable. In this case, it's going to be a variable. So we're going to undo that radical by squaring both sides. What we end up getting is 15 minus 2x is equal to x squared. So the square root and the square do cancel each other out. And what we have now is a quadratic equation. So in order to solve a quadratic equation, we need to get it equal to 0. So we're going to move the 15 and the 2x over to the right side. So we're going to subtract 15 and add 2x to both sides. And that cancels them out on the left, so that we get 0 is equal to x squared plus 2x minus 15, and that is our quadratic equation in general form. Okay, so what we need to do now is pick a strategy to solve. So you can use the quadratic formula, you could do completing the squares. I choose to factor. So I recognize that this can be factored. So I'm going to write my parentheses for my two factors, and the factors will be x plus 5 and x minus 3. So now I'm going to solve this quadratic equation, which means I'm going to get x plus 5 is equal to 0. That gives me x is equal to negative 5. And x minus 3 is equal to 0, which gives me x is equal to positive 3. So what I have are two apparent solutions, and what I need to do is check both. All right, so let's go ahead and check that. Check using, by substituting the negative 5 into my equation, simplify, and then doing it again with positive 3. So let's start with negative 5. So we have the square root of 15 minus 2 times negative 5. Let's extend that radical so it's over the entire expression is equal to negative 5. So 15 minus 2 times 5 is actually going to give us positive 15 plus 10, which is going to give us positive 25. So we're going to have positive 25 under the radical is equal to negative 5, and the square root of 25 is 5 is equal to negative 5. Now what you can see is that 5 does not equal negative 5, which means that negative 5 is an extraneous solution. So you would not list negative 5 as an actual answer when you were giving this as your final answer. Let's check positive 3 because it is possible for both of these to be extraneous. Let's just check to make sure. So we would substitute 3 into the equation. So it would be the square root of 15 minus 2 times 3 is equal to 3. 15 minus 2 times 3, 2 times 3 is 6, so it's 15 minus 6, which is 9. So it's going to be square root of 9 is equal to 3, and square root of 9 is 3. So this one checks out. So the solution that you would submit is only 3 and not negative 5. All right, guys, good luck.